today's session. Today we are going to talk about compute. So compute is, one of the most important thing in cloud. So that is where all our processing happens. Compute is nothing but what do you use for computing your day-to-day thing? You're using your laptop. So like that, any application needs its own compute resource, which is a server. When it was not cloud, it was all people used to buy servers, and that is where they install the applications, softwares, and run it. So what AWS is offering in the compute side, that is what we are going to see now. And before we go into that, we will just compare between our normal computer, what is there inside a computer, or what is needed for an application to run. These things we will understand. Then it will be easier to compare that with what cloud provides and what are the different terminologies in the cloud that they are using to make this work, right? Hope you're able to see my screen. Yeah. Okay. So Elastic Compute Cloud, EC2 is what they call. Okay. For compute, the basics are these things. Any computer you take, any laptop you take, the basic, hardware or basic thing that is available in your system is a CPU, where the processing runs. You have a RAM, you have a hard disk, and you have a network access card, which will connect you to the network. So can somebody tell me what is the difference between a RAM and HDD? I mean hard drive. This is something that we have all read in our colleges, right? So what is a RAM? What is a hard drive?
RAM is a temporary storage.
Okay.
Hard
drive is permanent. Is that the only difference?
RAM will make the computer so speed.
Process.
Sorry? Okay. So there are two things, right? For your application to run, to make its calculations, it needs a space to have all these data on, while processing. For example, you are, doing a calculation of 1 + 1 is equal to 2. So you need a space to store one. You need a space to store another one, and you need to, have some space to, make these calculations. So that is the, when your CPU is running, when you are making some computations, you need some memory to put that specific information while computing, right? So that is RAM. So that should be very close to your CPU, right? And that should be always connected to your CPU, and then only it can be very fast. So that is what is RAM is. RAM is basically to help the computation work. Hard drive is for storing. So once you do this computation, you create a file and store that information in a file that is going to sit there unless your another process comes and reads the file. That is going to stay there. It is not going to impact any other processing. So the storage of this particular file in a hard drive is not going to impact your computer process unless that information comes into RAM for any calculation. So the moment your application reads the file, then the entire file, let's say if it is 100 MB of file, that 100 MB data is coming into your RAM, which means that your CPU starts using that. Your CPU is 8 GB, 100 MB is utilized for having this data of this file. The moment it's closed and put in the hard drive, this 100 MB is gone, from the RAM. So your CPU is clear. So RAM keeps only data that is needed for, for the computation and it is, not, it is stateless, right? The moment you close RAM, whatever information was there is gone. So that is the reason if some computation is going on, your laptop is shut down, it's gone, right? So unless you have not saved it, it is not retrievable, right? So it is stateless, and hard disk is you can store the state. Right? Network access card, that is going to connect to your internet card. So these are the 4 basic principles. Okay, so these things are needed even when you are running something in the cloud. So what is that? How is that, how these cloud providers are providing that? That's what we'll see. So this is what you have seen. So CPU, that's, is measured in the gigahertz, that is, runtime, running speed. RAM is how much you are going to store. So usually you will have a RAM of 4 GB, 8 GB, 16 GB, depending on what you need. And your hard disk is huge, right? So on 2 TB, 1 TB, whatever it can be. And this is network interface card, that is either in the Mbps or Gbps, how it can transfer, how fast it can transfer the data between your computer and to the internet, right? So that is connected to your network switch. So this is a router. When you want to connect to the internet, you have a Wi-Fi router, which will connect your laptop or computer to the outside internet. Same thing is needed for a cloud provider also. Okay. So as I said, RAM is non-persistent storage. It's not going to persist, and hard disk, you will store the files. Okay.
But nowadays there is no STD, right? That are display only STD.
Yeah, SDD. Yeah. These are all the evolutions. I mean, the basic concept is the same. Yeah. Okay. So the same thing applies to a laptop or to a server, right? And what is there in the server? I mean, you will have a more specialized hardware. Server comes in a much higher price, and it includes redundancy as well. So you can start something and run it in your computer, okay? But when you want many people to be connected to your computer, you cannot just you can run your application from your computer itself, but will it hold all the traffic that it is going to? Will it respond to all the traffic, or will it be always be available all the time? You cannot keep your computer running. So that is why you go to server. So whatever you develop in your computer, you will move that to a server, so that that server is always up and running, that is connected to internet. And even if you are closing your laptop, your application is up and running, right? So that is where you go for a server. So now the same server has to come from cloud. You don't need to buy that server. Your cloud provider is going to provision that server for you. Okay, there are different types of servers we have. Okay, so there is something called web server, file server, database server, or some of the things. Web server means, I mean, you can run an application, which web application, where it will serve your request and responses. File server is just, it can hold your files, where you will access that server to fetch any file or update any file. Something like a hard disk. I mean, but server, that is basically it is a server, but it is only used for serving the files, right? So database server basically is specialized for database operations. So it can host any database. So why these are different is, I mean, the way it is configured will be optimized for either serving the web or serving file or database servers. So what can be the difference between a web server and a file server, right? The web server is going to have a large throughput, like lot of transactions per minute. Number of transactions will be high. Data transfer between for each transaction will be very less. Okay, but when you take a file server, probably the number of transactions will be less, but the data it transfers between transactions will be huge, because it will transfer a file itself. A web server will not send a file itself, it will send only data chunks. But a file server is going to send huge files. So if that server is optimized to handle large data transfer, then it can be a file server. Similarly, database, like you will have a lot of input output operations, right? So it has to ensure all transactions are processed immediately and are considered atomic in the sense, you cannot have like multiple transactions coming and updating the same table, but it gets hanged, right? So if you have provision to handle that is database server. So different types of web servers are available, and cloud providers, they provide different things as well. And you can have everything running in one server also, right? So that is where the concept of port is coming. So a server is nothing but it's like a an auditorium, right? Where a lot of things are happening. You can run different things. You can run a database there. You can run application there. You can have a file server separately. But this auditorium can have multiple doors, right? In one door you can access the files. In another door you can access your applications. So that is called port. So in server, if you take a server, there will be a lot of ports. So specifically, some of the there are few ports designated for some operations. For example, if it is web HTTP, 443 will be the port, right? So doesn't mean it has to go for 443. It's just a standardized thing, but you can even serve in any port that you want. It all depends on where you are serving. Okay. Any questions?
Do you have any example for a web server or a database server? Because what I'm saying is if I'm accessing an application, right? So if I'm accessing from a web application, any application, it will be redirected to DB.
Correct.
So anyway, interaction will be there. So you said, do we have separate any web server which is not having in the DB access or something? How come
Correct.
we have?
So this is how it will be. Our application, for example, metaphor strategy, that itself is an example. So the EC2 instance we have is a web server. So that serves the web. I mean, it is open for the port 443, which is going to serve request and responses. Any request can come into your server. It is going to send a response back. Okay. Our database is going to be served from a different server. Okay. So we have two servers. One, the web server, that is where the transactions go from the web to your server. That server is going to see, okay, this user is asking this information. This information is available in this database. So let me connect to that database server. Okay, so it's connecting to the database. That database again is sitting in another server. So that will give you the information. So that comes to your web server. From the web server, it will go to the user. Okay. Yeah. Any other questions? At this point. So now let's see, all these things are available, and there is something called virtualization. So what cloud providers do, they provide you virtual servers. They don't provide you, physical servers. They provision you some virtual servers, right? So if you see what is happening inside a server, for you to run your application without virtualization, you will have a server, I mean the hardware. On top of that, you will have an operating system that that is provisioned to run, and on top of that you will install your application. So if this is all available, then your server is available to serve anything, right? So the underlying thing is the hardware, then comes the operating system, then comes the application. Okay, this is the traditional way or the older way of running an application in a server. In this case, the operating system is tied to the server. Once you install that operating system, that is installed. You cannot change that. You have to, if you want to change it, you have to uninstall this thing and install another thing, right? So your application is tied to your operating system. There is no kind of, it's all done. I mean, you cannot, if your server is down, if your server is dead, what will happen in this case? So you will have to buy another server, install the same operating system there, install your application there again, build it. That is how you can come to live if your other the running server is dead. So what cloud providers give you is they provide you options to just migrate your application to any server. So we will see those concepts. Okay. So what virtualization means. I mean, not even going to cloud. This is about VMs, virtual machines. So what is a virtual machine is you will have a server, and on top of that you will have a layer called hypervisor. Okay, so these concepts are not going to be directly asked. Okay, but it is very important to understand the concepts that we will be seeing. Okay, the services that we will be seeing. So there's something called hypervisor that will be, that hypervisor is nothing but it's an abstraction layer above the server. Okay, and it can have anything that is installed on it can be, so this hypervisor will be if you have the same hypervisor in two different servers, whatever you have installed on top of it can be just migrated to that. It is not, you are not tying that to a server. Your server is actually underlying. On top of that, you are giving a hypervisor. This hypervisor is like, you can move around VMs on that. Remove this VM, install another VM. If VM is considered as a a hardware and operating system and application. If this is something, then you can just switch to different servers and it will run as it is. So it is not tied to the hardware itself. So if you want to run multiple servers at the same time, keep on increasing, you can just if you have this setup, server and hypervisor and the virtual machine, you can just replicate the virtual machine in every server you want, right? And even in the same server you can replicate these in multiple has a smaller servers within one server and run in different ports. Okay,
So we needed, for example, if I run the VM in a different servers, so I might need to use the same VM credentials or something for that.
To access the virtual machine, yes, but to access your server, that will be different. I mean, if you are asking, okay, this VM is serving this application, and I use this user ID and password to log into that VM. This VM is replicated in multiple different things. Yes, you will use the same thing. So what will happen in this case is now let's say 5 VMs are running, same thing. Same application is running 5 different VMs. 10 different people are giving request. So where will it go? Any idea?
First one.
Every first one. How is it first one?
The first one is completed, then only they will move the second virtual server.
We have not done anything. We have just okay. We have just installed this VM in multiple servers. Okay, unless we route it, it is not going to go anywhere. It is going to go only to the place where you are routing. Though all these are different things, all these 5 IP addresses will be different, right?
Yes.
So you can route only to one IP address. So even though you have 5, your request is always going to go to 1. Okay. So there is no use of having 5, correct? But how can you make use of it? That is where the next level of load balancing will come. We will be talking about that. So you have 5 different VMs ready to serve you. You have to provision that, okay, if 500 people are coming, send the first 100 requests to the first one. If the first one is running on its capacity, route the request to next one. Or you can do it anyway, split one by one. First goes to the first VM, second request goes to second VM, and so on. This concept is called load balancing. We will be seeing that. Okay, and this is the basic for that. So only if you can create virtual machines and run it in multiple places, you can handle that. So that is where this is coming in. It's very important.
So does it have elasticity or only load balancer?
Elasticity is nothing but you can expand. Expand means that is auto scaling. That's another concept of auto scaling. So that is again, so in this case we have said 1 and you have replicated that to 5. Okay, but what if you want to replicate to 500? You are going to get thousands and millions of records at the same time. You want to handle everything. So that is called, if you are able to increase your volume of VMs from few few to hundreds and thousands, that is called auto scaling, right? So can you do that without can you do that without having cloud storage? No, because if you have to go from 5 to 500, you have to buy 500 servers first and install them. And once you have this 500 servers, if you're not getting traffic, there's no point, right? So that is where again cloud providers come into play. They tell you, okay, don't worry. Today you have only 5 requests, just have one. Tomorrow you may get 500. Increase. We will automatically increase it to 10. Then next month you will have millions. Then automatically we will increase it to those many numbers to handle. You don't worry about the capacity, load, and all. You just install your program in this VM. We will take care of the rest. You are just going to pay for what you are using. That is the concept, right? Any questions, guys, on the who are connected offline? Okay. So this is what it is. Many VMs can run on a hypervisor, and that will be on a server. This. So VM can be moved from one server to the another if you have a hypervisor. There is no direct tie. So the VM is if you are having a virtual machine with these configurations, you can just move it. So when you provision a VM, right? So this is what they will give you. So they will give you a particular CPU, a particular RAM size, and a hard drive, and a connection port and all. Okay, and that is not the server, actual server. These things are available as a VM, and you are going to purchase that, and you can replicate that, and they can run it anywhere. So because in their servers they have hypervisors installed, so you just create it and tell this is what I want to run in US East 1, US West 1, wherever you want. You just take that and put it there.
It's purely based on the requirement.
Purely based on that.
So it is not about the mandatory thing to.
Yeah, you can run with one even a very small instance with whatever required for you to serve your application. You are not expecting anything until 1 year. You're just keep on going to develop, but you want that to be live. So you can run with one small instance, keep it open always, and test it out. Only after you are ready to deploy to open it up for others, you can expand it. Okay.
So in that time only the VM came, the hypervisor will comes into the picture.
Even now the hypervisor is there.
Ah.
Okay, but you are running in only one VM that you have purchased. What you can do is, let's say you want to move this from one region to another region. You have started a VM in one region, okay, and working on it. You want to migrate that to another state for easy access, right? You can without making any changes, you can just stop this VM and put it in another one, restart it, it will run there. That is the concept here. Okay. So this is exactly what is a VM we call here in a normal sense is the EC2 instance that AWS is providing, Elastic Compute Cloud, right? The VM is called EC2 in AWS. Before this, cloud providers came into play, VM existed. There were VM providers like but it will all be in the physical server in the office, but they all will be installed in virtual machines, not in actual, not without a virtual machine, so that they can move around when needed. They can shut off one server and just use the same VM. Once you are in a VM, you can replicate the VM to another servers. You don't have to deploy the code everywhere and all. So and all maintenance will be free, and you can restrict it to a specific CPU power specific RAM usage and all. So many enterprise applications, they always install their applications, create a VM first, install it, and then only use it. Okay. So EC2 instances you can purchase with any operating system like Windows, Linux, or Mac OS. They provide, and it comes with a variety of CPU, RAM, storage, and network. So they have a lot of different names for it will start from CPU. They call it as 1 core, 2 core, 4 core, 8 core. What it means is at the same time how many different workers can work. Okay, so 1 core means there is only one worker that is taking request and sending response. 2 core means same time 2 workers will be there processing 2 different requests. So 4 core, 8 core means so many things are there. Yeah. And RAM. So RAM, it starts from 2 GB to you can go to expand 32, 50, 64, whatever. And even this nowadays machine learning and all, they need so many number of TV size RAM is needed for machine learning activities and all. And it provides a networking capability also, so that it provides you a private network through which you can connect to your outside world. Okay. And the hosting server, so the underlying hardware, right, the server, that is completely managed by AWS. You are only saying what you want, like in CPU, I want this amount of CPU, this amount of RAM, this amount of this kind of network thing. So you give me, so that underlying hardware is managed by AWS. So there is no thing that this server will go down. They are going to take care of that. You are not going to manage anything on that. You are just going to manage what is going to be there in this VM. So they have provided this VM. On top of that, you are going to operating system is also coming. So you are just going to install your application, needed a specific software there, and you are going to just manage that. So there are a few key terms that we will be seeing all through the course. EC2. EC2 is Elastic Compute Cloud. So this is the virtual server, and it's called an instance. We call it as an instance. So when we say an instance, it's either it's a EC2 instance. Okay. Why it is called an instance? So that is there can be multiple instances of the same server running, which means that there are n number of same servers available, right? Okay. And AMI. AMI is AWS Machine Image. So this is something. There are two ways to see AMIs here. Okay, one, AWS is actually providing pre-installed EC2s. Okay, you may have a need to run a specific. Let's say, let's take this way. There is one company that is specialized in a software. They have their proprietary software, and on top of that software, you can go ahead and build applications. Okay, so there's a specialized software. On top of that software, you can build your own applications. Okay, and run it. So that company may come up with an AMI, which is like an image that is a pre-built server. They provide, they configure that with all the necessary operating system, software needed, everything. Okay, and they have their software also installed. You don't get that software anywhere. So what they provide is they provide an AMI image of this instance. Okay, they have a server, they have built this. So they are going to give it to you or to 1,000 people, so that all of you can go ahead and build your own applications. The underlying thing is their software, and below that operating system, then the server, all these things. So one running EC2 instance configured with all this, you can create an image of it. Image means just to take a snapshot of it. Okay, like a photocopy. Okay, so once you create a photocopy of it, that photocopy is not, a running one. Okay, that is just a data, just a data. Okay, this data they can provide you as a file. Okay, you can take this file and say AWS, hey AWS, create me an EC2 instance with this image. So what AWS will do is this photo, it will create an actual server. So everything that another company has installed and run, they had it as a running server, that is coming to you as a image. So you can go over and modify that on top of it. So that is what is called a AMI, Amazon Machine Image. Okay. So as long as it is an image, you cannot do anything. As long as it is an image, you cannot do anything. An image has to be converted to a EC2 instance that AWS will take care. Okay. Another one. So this is if you look at AWS and see if you want to create a EC2 instance, they will upfront ask you, do you want to create an EC2 instance from an existing AMI which is provisioned with pre-configured with something, or do you want to start from the scratch? So you can either start from the scratch or take from existing ones. And there is something called marketplace. So where you can go, you can search the marketplace. As I said, one company specialized in this thing. They have their own AMI. You take that AMI and just build your application on top of it. Otherwise, what you will be doing, you will be taking a plain EC2 instance with an operating system, and then on top of it, you will install whatever is needed. All these things are not needed. You just have to go ahead and update the code. So this AMI is available. Create a, take that, run it. Okay.
இதெல்லாம் நான் கண்டுபிடிக்கலாம் தேவையில்ல. அது ஒரு சைட் போனா வந்துரும்.
Ganesh, can you mute?
I think it's better. Another example. Okay, so you have built something. You are running. You have you are developing an application. You have taken from the scratch. Okay, taken an EC2 instance from the scratch. You are you have installed the software. You are building the application. Everything is done. Okay, now you want to do the same thing or create a replica of it in some other region or somewhere. Okay, or you want to just run two servers at the same time, right? So the same image has to be created first. So they take a snapshot of what is there. So this image is available. Now you will tell, okay, I want to create another EC2 instance, use this image. This is my custom image, use this image. Another thing is immediately available. So if you spent 15 days building all this one server, and you are sure that everything is done and this is what is going to be live, and I want to replicate to 1,000 things, then this is what you will do. You will be having this EC2 instance with all the setup. You will create an image and you will tell AWS, hey, create 10 more images of it. Or when you provision auto scaling, you will say, hey, when you want to auto scale, use this image. When you see, things are traffic is increasing. Let's say you want to see, you can see like this. In a normal case, your CPU utilization is 50%, less than 50%. But in some case, when the traffic is going to go high, or when you expect too much traffic, let's say it's keep on increasing. Okay, by the time it reaches 70%, you are sure that it's going to cross 100%. So immediately you can create another instance. So if you have this AMI and set up that auto scaling to any number, so what AWS will do is, if it sees 70% on your first server, it will automatically go take the image AMI, create an EC2 instance, and make it available for you to take the traffic. So if this is 70% and this also goes to 70%, same thing happens and another instance gets created. Okay, that is what is AMI is.
So how the AMI will be controlled? Because if many companies having in a cloud and they having a server, so each and every server having an AMI. So is that secured because AWS is having all this AMI, so they are giving AMI to the other companies as well. So it might have my AMI will be shared to some other person. They will.
No, it's not like that. It is not, AMI is not like, see, it is shared only if you want to share. Okay, so your EC2 instance, you are creating an AMI means only you can access. Only if you put that in the marketplace, somebody else can see. So others have created this AMI specifically so that others can use their product, or they have purchased this product and it is easy for them to just go ahead and deploy an AMI instead of building it on their own, making it easy for the people so that you don't even have to worry about this thing. You want to use my product, so I've developed a software and that software has to run in as a separate server for you. I'm not going to run that server, so I give you an AMI. You just run that AMI in your cloud thing, so your data is only with you. Even though you want to use my software, you are not using my your data is not coming to me. You are using the entire setup at your side itself. Okay, so everything is with you. So that is why different companies will produce AMIs and provide it.
Provided to AWS.
Yes, AWS, and people can pick
Yes.
from there. Okay, so there are different types of instant types that you will see if when you are taking an EC2 instance. We will see that instant type is nothing but micro, medium, large, extra large. This kind of instant types are available. They call it A1, A2, A3. There are different naming conventions that are available. We don't have to worry about it. It just goes from small to very high. That's all. Okay. And it will be depending on how it is provisioned. Some types will be provisioned for, as I said, web traffic. Some service will be, some AMS or instance will be provisioned for file traffic, right? Something will be for database transactions. So depending on that, you will be choosing your EC2 instances. And okay, EBS, Elastic Block Storage. We saw one thing here, that is hard disk. Until now, we have seen, EC2 instance provides you RAM. Okay, but we did not say that it provides a hard disk file. Okay, so there is a special service called Elastic Block Storage, which is like a hard disk. So when you purchase a EC2 itself, it will ask you how much Elastic Block Storage you want, like how much hard disk you want. So you will also choose that. There's nothing but a hard disk. Okay, so it will be attached to that EC2 instance. So since it is like a hard disk, you can take it out, put it in another EC2 instance. Okay, so this you can detach it from one EC2 instance and attach it to another one. Modify means
Storage.
yes, you can upgrade. They will automatically, upgrade it. And okay, and next one is security. So this is EC2 instance is a server. So now you want something to secure your server. You have ports in it, right? So anybody can access that port. How we are going to control who can access, who should not, which port can be opened, which port cannot be opened. Okay, all these things are called or firewall rules. Okay, these rules you can set up through the security groups. Okay, we will see that in action. Probably if not today, tomorrow we will see all these things in action. But this is the concept. I mean, what is going to secure your EC2 instance? Security group is going to secure the nearest or the closest one that secures your EC2 instance is the security group. There are multiple levels of security as we go, but this is the most closest thing to your EC2 instance. It is like a firewall around your EC2 instance. Any questions, guys? Let's go to the next one.
Yes, Prem. Could you please go back to the previous slide?
Previous slide.
Yeah, so instant type is based on the traffic, correct? For example, if I received the lot of traffic means I need to increase the RAM.
Instant type is something that, when you are provisioning your EC2 instance, you will be selecting an instance type. So different instance type have different, combinations of your CPU, RAM, and networking. Okay, which means that some instance types are provisioned to handle a certain amount of, high throughput traffic. Okay, lot of input output operations. This cannot handle, if you take this instance type and serve it as a file server, then you will throttle, because it is not provisioned for that. So this is a type that this instance is specific to kind of a web server. This instance is specific to a database server. Okay, so if you will not know by looking at the name of the server, but if you see what does that, see the description, they will tell you this is provisioned for handling fast responses. This is provisioned for handling large data transfer. This is provisioned for handling machine learning load. Okay, different types are there that are specialized and provisioned for a specific. There is always a general purpose thing. Okay, all these things are given with normal weightage. It is not specialized in anything, but you can, to start with, you can take a general purpose one, build your application, then you know what is the most important thing for you. Then you can switch to a different type that will serve you. Right. Okay, Jain.
Yeah, Prem, but still more, could you please share some realistic sample of so that it will be really helpful for me, because as of my understanding, so variety of different combinations means I have one applications. If the application is with a huge load means I need to increase the different RAMs or card disk based on the request. So if my understanding is not correct, so could you please share exactly?
Correct. What you said is right. Your understanding is right. What I'm
Okay.
saying, when you choose an EC2 instance, you will be choosing a type. That
Okay.
type will be based on what you need. Initially, probably you will choose a general purpose type. Okay.
Okay.
Then based on what your application is going to need. Okay. Initially, probably you will be having one server running your application itself in that, your database itself in that, your files also stored there. Okay, all these things you may be having in one server, because you don't want to spend for 3 servers initially.
Okay.
One server is, if you say $50 per month, 3 servers, $150 per month. Are you going to get back anything out of it? Until you develop and sell your product, you are not going to. So for you to develop, you only need one server. You can go with a general purpose thing to see how your application is building, what is needed. Then you determine, okay, now I see that I need a separate server for database. I need a separate server for web service. I need a separate server that can serve the files, right? This is where you will go for a different instance type. Okay, so from general purpose, you will move to high throughput cases or high volume data transfer types. Okay, so that is what it is. We will see about these instance types. You're able to see my screen, right?
Yeah, Prem.
Yeah, so this is your different instance types. Okay, so there are
Okay.
766 different instance types available. You see, just compare between a few of them. They call T1 micro, T2 nano, T2 micro and all. Okay, you can see what it is. So network performance, and this is very low. Okay, it is not going to give you any good network traffic. If your traffic is going to be high, your micro is not going to work for you. And the memory, it is giving only 600 MB. Okay, and vCPU is just 1. Okay, but if you take this X2 large, then you have 4 vCPUs, 16 GB of memory, and your network performance is moderate.
It's like a AMI, correct, Prem? So if I select this instance type and if we are creating the new server, so we will set up a new server like this, like I
Your
go for C.
server will have this configuration.
Yes. Okay.
AMI is different. AMI, even a plain server is an AMI. You can create an AMI out of it.
Okay.
Okay, even okay. When you are selecting the, let's say I'm selecting this, okay, and creating what in the background AWS does is they have an AMI that matches this configuration without any further things installed on it. So they create a copy from that. From that AMI they will create. Okay, that is one example of AMI or one usage of AMI. Another usage of AMI is you have created your application, you have done a lot of things on it. Over a period of time, you have installed so many packages and all. It's all up and running. Okay. If you want to run the same thing in another server, do you want to do this all these exercises again? No. You just say that take an image from this, one click, it creates an image. Next click, create another EC2 instance from this image. Another 2 minutes, your server is ready. Right? So if you are updating your server, say the first server, okay, you are probably going to create a backup, right? So let's say every day you are creating a backup. Every time you are installing a new thing, you will create a backup so that whenever something goes wrong, I can go back to the previous server instance. This is another example, right? I'm telling about AMI. So today I have deployed, let's say a huge release, okay? And before that, until yesterday, my server was working fine. Today I'm deploying, a lot of changes are going to happen to my server. It is possible that something can break and I may have to go back, revert this entire server, right? So what I can do is I can create an AMI before I deploy my code or any changes to that EC2 instance. I will have an AMI images there. Okay, if something goes wrong, I can always go and say, hey, create an EC2 instance out of this, shut down the previous one, so that I have gone back to the previous one. Okay, this is another example of AMI. Okay, got it, Jay?
Yeah, got it, Prem.
Yeah.
The process of moving general purpose instance to database instance is very taken.
It is not time taken. They take it. It will be minutes. Okay.
With the instance type, we haven't someone run something, right? So this all are instance already created one, right? Already created, someone is offline.
AWS has provision, has this all these these 766 different AMIs are available. You can assume like that.
We can choose it here, or else we can customize whatever we
AMI, AMI I'm saying is don't confuse AMI with this. In the background, they have AMI for this.
I'm saying this is EC2 instance, right?
This is EC2 instance.
EC2 instance.
Yeah.
So we have, there is a default EC2 instance, Amazon having 766 plus.
Yes.
If we can go with this,
Yes.
or else we can
Yes.
customize
Yes. Yes. Absolutely. So you can see it here. So images, you see that, right? AMIs. This is my AMIs. I don't have any AMIs. Okay. If I create an AMI, that will be available here. This is catalog, their marketplace. So Amazon itself is providing different type of AMIs. That comes with Linux, that comes with the Mac OS. Okay, and this is all Amazon AMIs. And if you go to the marketplace, so many people, OpenVPN. These are all different companies providing their AMIs. You can select from here and create an EC2 instance out of it. Okay. Subscribe on instance launch. Somebody will be having subscription and all that we don't know, but that's how it is. Okay, from here you can launch an EC2 instance. And volumes, EBS, I told you, right? So that is is volumes. I don't have any volume. I can create a volume. So it says, this is general purpose, or it is provisioned for input output operations. IOPS means input output operations. A cold HDD means it is, like, hard disk only. Throughput optimized. Throughput optimized means, input output operations are specifically for database operations. Throughput is web traffic. Okay. And magnet is kind of, high performance one. So different volume types are also available. These are all different types of hard disks. I mean SDD, hard disk or SDD, the EBS thing. And you can choose what size you want. And you can also provision what kind of throughput or input output operations you are going to have. It will provision it accordingly and give you a general purpose. If I choose, you can set it as 3000 and throughput is 155 Mbps. If I go with the provisioned input output operation, I can modify anything and do it. Okay, so basically the underlying hardware of the disk will be provisioned for that. You can specify what you want here. Okay. Is it time? Is it okay if we go another 5-10 minutes? So the benefits here, elasticity. You can easily launch hundreds and thousands of instances within minutes. You don't have to wait for anything. Just say I want 1000 instances of this one. In the next 5 minutes, you'll have 1000 running. Only thing is your bank, you will be bankrupt. Control. You have, you control it with full root and admin access. Even though it is, the underlying server only they are hardware only they are having, but whatever is running on that to install or anything, EC2 instances, it is all you manage. Okay, it is not AWS manage, it is what you manage. So that's why if something goes wrong, we go inside the instance, restart it, or install. We need any new package to install, we install it. So it's all we manage. Flexibility, choice of you can, you have seen 766 different types where there are instant types, different softwares, different operating systems. So all this flexibility is there. Reliability, it's highly available because AWS is managing that. They provide you high availability. There is no point that it will go down. If you see the benchmark, they give 9.9999 or 99.999, 11 nines they call 99.99 percentage of availability in a year. Okay, and secure. So fully integrated with Amazon VPC and security features. As I said, security group is one, but beyond that, there are few other things. So VPC is one, we will see that. And there are many security features that you can apply to your things. Cost effective, as we know, it is pay for what you use. If you want to handle 1000 instances because of your volume, you are going to scale that much and you can use it, and it's going to automatically scale down if you have provision like that. So you are not going to run any server when you don't need to. So it is very cost effective. Okay. So EC2 instance placement. So now we have seen just a server. So how it is actually located in AWS. How is AWS having that? What are the different levels, right? The first one, the top one, the outer side is a region. Okay, so you can see in the AWS thing, you will see
Yes. What you mean?
this is the regions. So in these regions, they have their data centers. Okay, our server is going to sit in one of those places. So whatever is selected here, that will be the default one where our server will be launched. Okay, so that is the region. Then within that region, whenever we create an account, right? So they provide us a VPC. VPC means virtual private cloud. So the moment you go ahead and register for AWS and pay, give your credit card, they give you a private cloud. which means that nobody else can access that. You have your own private cloud. Whatever you create on that is basically that is given an IP address. One IP address is given to you that is specifically only for you. Okay, you will not know that, but AWS will manage that. Okay, and within a private cloud, there are availability zones. So within a particular region, there may be different availability zones available. Okay, availability zone means if it is a if you take as a state as a region, availability zones will be, Chennai will be one availability zone, Coimbatore will be one availability zone, Kanyakumari may be another availability zone. Okay, so why they have availability zones is even if one zone goes down for some reason, some earthquake or anything, okay, and that is cut off from network, it cannot, nobody can, access their data, their applications. Having your instance in different availability zones will help you, handle that disasters. Okay, so that is what is availability zone. Simply think like a region is a state, availability zone is a city. And subnet. Subnet is a group of IP addresses within a VPC. Okay, so this is a little network concept. So IP address, if you see, there will be range of IP addresses. So when you specify a number like 10.0.0.0 -24 means it's a range. Okay, I'll explain that number concept there, but it is actually a range of hundreds of IP addresses within that. It goes from 0 to 32. You can say the number after the IP address that can go from 0 to 32. 32 means just one. Okay, just one, that particular IP address alone. Okay, it deals with the binary number concept here. Okay, when you say 2, so 0 means 0 means just sorry, 32 means that just that number. 32 minus 0, you can call 32 minus 32 is just 0. If it is 31, that IP address, right, 1.0.0, that is, you can convert that into a binary number. Okay, so 1, if you convert to binary, what will be the what will be the case? 0.0.0.0.1 dot 0.0.0.0.0 like that. Okay, so when you say /32 or /31, the last 2 bytes can be yours in that range. Okay, which means that 01, 00, 10, 11. So these 4 numbers are yours. That is the range. Okay, so 4 IP addresses are available for you when you say one number /31. When you say /33, okay, 30 means that 32 minus, sorry, 1 means just one number, right? 32 minus 31 means 32 minus 1 is 1. So only the last digit can be changed. So two IP addresses, 0 and 1. 2 means 4 IP addresses. Then 3 digits means how many numbers? 8 IP addresses. That is a range. I'll show you an example of that calculation, but that is how IP addresses are defined. So when we say subnet, this group of IP addresses given to you, you can take, my IP address, if it is 100.0.0.0, I can have, how many in that totally for one number, it is, I believe 128. No, not 128. There are so many things possible. I can say 1,000 IP addresses in that range will be one subgroup. Another 1,000 will be another one. You can split your VPC into different subnets. Why you want to split it? You want to keep them separate. Okay. For example, you have a VPC. Okay, you are going to have 10 different EC2 instances running. One will be running for your finance application. One will be running for your administrative application. One will be running for your data processing. Okay, so these are two different organizations. You don't want to, have anybody with any instance in one group have access to another group. Okay, so in that case, you can create different subnets and put your instances there so that they will not have direct access within that. If you have, so if you are in the same subnet, one EC2 instance can talk to another EC2 instance. They can easily, they obviously have the access between them. Okay, because it's the same subnet. That again is governed by the security group only. So security group can say, okay, within the subnet, people can access. Okay, so if that allows your two instances in one subnet can talk to each other. If it is, in another subnet, you will not, your instance cannot connect to that instance. That is how you are, separating your administration or security of your instances. So availability zone, as I said, is a city. Within the city, let's say you have different streets. Okay, so the entire city is yours, but you are defining. Okay, the first street is going to have only this. Second street is going to have only this people, like that. Okay, so that way, and then comes the security group. So security group is like a door for your house. If you consider your EC2 instance as a house, security group is your door, subnet is your street, availability zone is your city, and your VPC is your VPC is kind of imaginary location given to you, okay, within your state that can span across availability zones. Okay, and region is your state. Understood?
Security group is called as a firewall. Firewall.
All these are firewalls.
All these are firewalls.
Security group is governing only that EC2 instance. It is not governing another EC2 instance. One EC2 instance will have one security group, one door. Okay, this door cannot be governing another house's door. Okay, but you can configure, copy this door to another door and map it to another security.
If only the subnet or the EC2 instance is in the same subnet. If it's in a two different subnet, we can't able to do it.
Yes, there again, you will have, see, by default, you will not, your EC2 instance will not be able to talk to your another subnet unless you specifically give provision. Everything is possible. Okay, but the difference between putting it in the same subnet and outside, different subnets is you specifically want to differentiate. You don't want to give access by default because your security groups allows that. Okay.
Yeah, Prem. So let's come to the availability zone. Means for the application running on all the three zones are the backup only available for all the zones.
A good question. So it depends on, again, how you are going to configure. Okay, so they are providing you these facilities. Okay, assume this, you have your by default, they will run your EC2 instances in 3 availability zones. Okay, by default. You can say, I don't want, I just want to run in one zone. That is your risk. Okay, that is your risk. You can say, I want to run more than 3 availability zones. That is you are going to pay for additional for that. Okay, so by giving, making sure your instances are running in 3 availability zones, they are going to, ensure the, reliability, right? But if you want to take a risk, you can take a risk. If you want to be more cautious, you can be cautious. You're just going to pay more or pay less. Did I answer you, Jay?
Yeah, Prem. Yeah, got it.
So this is again the instance types we already spoke. So general purpose is for, balanced computation, memory and networking. Compute optimized. So if you want like, high processing power, then you go for compute optimized. Okay, so here the computation, the calculation is taking more precedence. Memory optimized. So you want more space you want more RAM to process. Okay. Not only your processing speed can be less, but you are dealing with large, huge data in your processing. Then you need memory optimized. Accelerated computing, like in this itself, you have some more additional power added to that, and that's accelerated. Storage optimized, as I said, read-write operations. You will be accessing files. You will be accessing files from a storage, so that processing has to be optimized. These are different ways you can have your instance types. Any questions? I think it's pretty clear, right?
We can able to make a multiple instance, right? Types.
Yes.
The combinations.
Yes.
whatever we do.
Yes. And based on the pricing, there are different instance types available. On-demand instances. Okay, on-demand means you are going to pay for what you are using by hour and second. So you just take it on demand, run it, shut it down. You're just going to pay for that few minutes that you are running. Especially when auto scaling is needed, you want on demand. When I need, I want to install. When I don't need, I want to shut down. That is when on demand instances comes to play. Spot instances. So this is very, very economical. Spot instances like let's say you have always need 10 instances. Okay, you will provision on-demand instances, or there's something called reserved. We will first talk about reserved and then come to spot. Okay, that will be better. Reserved is you are reserving, saying that okay, I always need 10 servers, 10 EC2 instances, this configuration. I'll pay you upfront. What are you going to give me back? I mean, what discount you are going to give? So they can give you up to 70% discount. If you are taking for 3 years, okay, you get 70% discount on your cost. So one server running for 1 month, $50 on demand. If you take it for 3 years, then calculate the cost. If you're running it for 3 years in on demand, that is 70% higher. Okay, that is reserved, but you are going to pay upfront. You will pay, instead of paying $50 a month, you will pay $250 upfront. Okay, that is reserved. Dedicated is physical server. I mean, this is needed in some cases where you want licenses to be. There are some software licenses that work only based on the MAC address of your machine. Okay, your server cannot be. Usually, what happens is when you in on demand or any instance, you don't know where the instance is going to be created. Okay, so you will ask for an instance, it will be available. Let's say today they are giving you from availability zone one server, they pick up and give it. You stop it and restart it. It may be started in another server, another actual physical place. Okay. So in this case, your underlying configuration is different. Your MAC address and everything will be different. Okay. Unless your application doesn't depend on that, you are fine. But there are some licenses like, earlier we used to have this license will work only in this computer. Microsoft license you buy, this license will work only in this computer. You cannot install that in another computer. So they lock it by the hardware. Okay. So in those cases, you need dedicated hosts. Even though you will be stopping and restarting, it should not restart in another place. It has to be the same hardware. So that case, you can say that I want this dedicated host, and you will pay more for that. That's it. They can provision for you. Okay. That is dedicated. Now coming back to spot instances, this is something like Amazon will have, because they have to give you so much of, they have to serve so many people, right? So they always have a lot of things available, right? So there may be some instances, or they will be running something which is not used by anybody, right? Out of let's say 1,000 servers running, only 500 servers are being actually used. Okay, so other 500 servers are kind of available. When somebody wants to auto scale, they will auto scale into these things. They will provide like spot instances saying you can bid for it. Okay, they will provide like, you can take the server for 90% less price at this time. Okay. So it will be like those spot instances will keep on coming, whichever is idle. Okay. Like you can provision, like if I want to auto scale, like from 10 to 100, I can say 50% of that auto scaling thing, I will go for spot instances. So I will say, but these spot instances are short lived. Okay. They are not long lived. So when somebody, it will be for, 1 hour or so. Within that 1 hour, if your job is done, you are good. So you can go for spot instance, pick one at a 90% lower cost. 90 is a benchmark, it can be 60, 70 or whatever. And run it and you are done. Then if the demand increases, the 90% will go to 80%, right? So if you are saying I want this by 90%, you are after the 1 hour it will be closed, and somebody else who is giving for asking for more price, they will get it. So this is called spot instances. But they will give you, if your 1 hour is going to complete, your instance will get notification. You will have to provision your instance probably to stop it, or save your data of processing and then continue with another server. All these things are possible. So this is called spot instance. All right. So this is the last slide. So every instance will have something called metadata and user data. Metadata, this is why this is mentioned, this will be asked in the questions. What is a metadata? What is a user data? Metadata is nothing but information about the instance. So you have provisioned with the EC2 instance type, something and all. I have configured it. All this configuration will be available in the metadata, right? You can know about that instance by calling this, the IP address is the IP address of your instance. By latest class metadata will give you about that instance. User data is something that this will be used whenever the instance restarts. So you want to pre-configure something. Okay. It's like, okay, a quick example is an EC2 instance. Okay, whenever it starts, it has to start a server running in port 443. It has to open that port that should be available, or it has to install the web server there and open that port. This can be some lines of codes that you want to run in your server, like immediately after your server is up, you want to run some commands, okay, before everything else starts. That is called user data. So you can put whatever commands you want to put on the server as a user data, so that when that server comes up, automatically it runs and that is available for you. You don't have to manually do anything. That is user data. Okay. So user specified instruction during launch can be run at start of the instance, every boot or first launch. You can specify when it should run. Okay. So these are the two things. Like for example, pull latest code from the Git. So restarted the machine, and I don't want to go and say pull the, do the Git command. I can provide the command in the user data, and it can run automatically, fetch the Git information. Installing a database server at launch. When it is launched, I want to install the database server so that it can be connected. Okay. Download the latest version of the software. These are all kind of examples. Okay. That's all about it for today. We will see, few things in action, possibly by tomorrow. Okay. Or you can come back with any questions. If you have AWS account, please go ahead and see all these things by yourself. Then you will get a lot of questions. Why this? What is this? What is that? And all. We can answer that. That will be beneficial. Okay. This is all theory, but this is, I think this is all the concepts. There is nothing to run and show. Okay, you can see what is there in their marketplace and all. That's it. It is all like, buying a product. What is the specialty about this product? That's all. Yeah. Okay. That's all, guys. Any questions? Another 2-3 minutes. Otherwise, we can write up.
If the load increases, I need to create an instance from my AMI. How the host, how we can.
It will be it will
on
cost.
the
That is what
time of the using.
from the moment it is started. From the moment it is started, you start incurring the cost. If you terminate, it stops. Thank you. Thanks everyone for joining.